Hi everyone, welcome back to the channel. Today we will learn how to convert non-deterministic finite automata into deterministic finite automata by step using an example. If you are studying automata theory or theory of computation, this video will make the concept crystal clear. Let us see some of the example. One such example I have taken here: A bar B star ABB. Before converting from NFA to DFA, first you have to construct a NFA for this regular expression. So first A bar B will take. So that is a color coded here, A bar B star. First you have to take either A or B will accept. The NFA will be like this. Either it accept A or B, starting state will be the 1 for only this. Suppose there is a star also there, we need to take other two state. One is for initial state, another one is for final state. If I take individually A bar B star, so this will be the epsilon NFA. In this expression, another part will be there, that is ABB. How do you convert that? How do you construct for that NFA? So this will be the only A or B star. This is entire diagram. I am showing it in this diagram, indicating this color coded red color expression. In another expression is there ABB. So how do you construct? This will be concatenated with this expression. First expression ERB star followed by ABB. So then if I take 0 will be the initial state, 10 will be the final state. This is entire epsilon NFA, which will indicate for this expression ERB ABB. Now you have to convert in this video this expression. If I take and convert it into DFA, let us start now. So first, before taking this, we need to know the definition of e-closure. E-closure is a set of state which are reachable from Q without taking input. That means where there is a epsilon moment between the state, right, that it can say it is a epsilon closure. I will be indicating in this example, I will showing which are the state can reachable from starting state without taking the input, that means epsilon moment. E-closure of 0, which it can be go to 1 and also will go to 7. E-closure of 0, it will go to 1, and they have color coded here. It will go to 1 as well as it will go to 7. I will write 0 including the source node, source state. It may go to 0 to 1 and also will go to 7. Right, I will be added to this. In turn, from 1 you can able to reach 1 to 2, also it's 1 to 4, that also we have to include it. Then you can rearrange them. So 0 1 2 4 7. So you can be rename it by state A. So why do you use this? It can be any user defined label you can give it. Need not to be give only A. In this case I am giving label A for these states. The state A is representing 0, 1, 2, 4, 7. Right? So again for this state A, find a transition on input A and B. delta of A, capital A comma small a, which are the state have a transition for this state A, capital A. It can have a transition from 2 to 3 and also 7 to 8. So look at this. I underline this 2 and 7, 2 and 7. At the same 2 on A it will go to 3 and 7 on A will go to 8. So then you can include this. For this again you have to find out the e-closure of delta of A comma A, or I can include 3 comma 8. So that means e-closure of delta of capital A comma A. That means nothing but 0, 1, 2, 4, 7. That is capital A is nothing but this. Right? So where do you have this epsilon transition? 3, 3 on 3 to 6, 3 to 6, and also 3, it will go to 6. In turn also will go to 7. Look at this. 7. And also will go to 1. Right? Look at this. It will go to 7 and 1. From 1, you can able to reach 2 as well as 4. Right? Look at this. Right? So can include all of them. It is for e-closure of 3 comma 8. This is for only 3. How do you get this? E-closure of 8 is 8 itself, because you are not able to reach any other state without taking input. Without taking in. So that node, that state it can include it here. So again you have to rewrite this, rearranging them. So this is not same as A, capital A. You can call that is a B. Now delta of A, capital A comma A will go to B. So there is, look at this, will go delta of A, small a, delta capital A of small a will go to state B. So is that is over on capital A? No, you have one more input B, small b. I'll take that delta of capital A comma B. Again have to find it where and all it have a transition on B. So 1, because since capital A have state 4, it can have a transition from 4 to 5. So that means 5. Only 5. Rest of the state we don't have any transition on capital a small b. Right. For this again you have to find out the e-closure. E-closure of delta of A comma B nothing but 5. So from 5 you can able to reach 6. Okay, 6, then 7 and also 1. So you can reach to 7 without taking input. From 6 to 1 also not taking any input. Okay, so then from 1 you can able to reach 2 as well as 4. So all of them you have to include it here. So what is that now? So we can rewrite 1, 2, 4, 5, 6, 7. So which is not similar to A and B, you give a name C. That means we get a new state on capital A, B and C. Now you have to fill the state transition table. Capital A, delta of capital A on small a will go to B. Delta of on B will go to C. So once you understand A on transition is over, next new state is capital B. The capital B is nothing but 1, 2, 3, 4, 5, 4, 6, 7, 8. Right? So now for this again you have to find out the transition on input A, small a and small b. So for this delta of B comma A, so we can have transition on A only 2 and 7. 2 and 7. Okay. So 2 on A will go to 3 and 7 on A will go to 8. So we have to include these two states. Again you have to find out the e-closure of 3 comma 8 is nothing but delta b comma a, which you can get again. So e-closure of 3 is, will go to 6 as well as 7, and also will go to 1, from 1 to 2 and 4, right? So look at this. I have color coded. Clearly observe the slides. You can identify which are the state you can reachable from the starting source state. It's 3 without taking input. Okay. So now all the state have been added to this set. Okay. So now 8 is also been added, because e-closure of 3 is 3, 6, 7, 1, 2, 4. Then e-closure of 8 is 8 only. It will not go to any other state without taking any input. So you can rearrange them. We will get 1, 2, 3, 4, 4, 6, 7, 8, which is similar to the state C. Similar to the state C. Sorry, state B. It's similar to the state B, because it is already have labeled them. Because when you take the e-closure of 3 comma 8, you will get the similar set of states 1, 2, 3, 4, 6, 7, 8, which is similar to B. You can rename them. Okay. Now, so on B, delta of capital B comma small a will go to B only. Look at this. It will go to B only. Then, so then on B, so delta B, capital B comma B, again you have to have only transition 8, right, and 4. Look at this. 4 on B will go to 5, 8 on B will go to 9. Okay, so we have underlined this. B on 4 on B will go to 5, 8 on B will go to 9. Then again you have to find out the e-closure of delta B comma capital B comma B are nothing but 5 comma 9. So then e-closure of 5 is what? The 5 is already I color coded it, right? Underline that. So e-closure of 5 is 5, and it'll go to 6, and 6 from 6 to 7, and also will go to 7. Look at this. So this 4 state can audit them. Then from 1 it will also go to 2 and also 4. So this also have to audit it. Okay. So now 9. How did you get this 9? Then you can get only e-closure of 5 is 5, 6, 7, 1, 2 and 4. But we have one more state is 9. So e-closure of 9 is only 9, which is not go to any other state without taking input. Just added them. Then you have to rearrange them. We'll get 1 to 4, 5, 6, 7, 9, which is not similar to any other state already. We label it. We got new state A, B, C. You can give a new name D. Then delta of capital B comma B will go to the new state D. So D. Then B is over, which is the next new state C. C is nothing but state 1, 2, 4, 5, 6, 7. So now I'll take this. Now we have to find out the transition for C on input small a and small b. Delta of C comma A, these are the new state. The one is on 2, another one is 7. So 2 on will go to 3 as well as 8. So E closure of C comma small delta of C comma A is nothing but a 3 comma 8. 3 comma 8 we have already find it. E closure of 3 comma 8, it will go to 3 to 6, 6 to 7, and also 1, 1 to 2, and 1 to 4. Look at this. All of them can be included in this state. Okay, so all of them are color coded it. So then also we added T8 because the closure of 8 is 8 only. So you can rearrange them, which is similar to the B. 1, 2, 3, 4, 6, 7, 8. You can need not to give a new name for this. We'll give a same name, capital B. Okay. So C on delta of C comma capital C comma small a, which will go to B. X. Okay. You didn't get any new state from transition on capital C on A. Let us find the another transition for input B, small b, delta on capital C comma small b. Look at the transitions. Where do you find the transition on small b? So look at the state 7 and 4. So there is 1, 4. Another one is uh, you didn't have any other transition, but only on 5. Okay, we include e-closure of 5 is the e-closure of 5 is 5, 6, 7 and 1, 1 to 2 and 4. Look at this. So just look at the color coded here. 6, 1, 7 and 1 also will go to 2 and 4. You can rearrange them, which is similar to C. It is similar to C. You didn't get any new state. Can call that is you have to delta on C comma capital small b will go to capital C state capital C. Again, what which is the next new state, capital D. I'll take a capital D delta of D comma small e. So where and all you will get the transition for input small e and small b. 2 and 7, 2 and 7, look at this, 3 comma 8, which is similar. We might have already observed, you already know it, how to find the transition for this, which you can 2 on A will go to 3 and 7 on A will go to 8. These two state will get 3 comma 8. Then for this again find out the e-closure. E-closure of delta of capital D comma small a, again nothing but 3 comma 8. So 3 e-closure of 3 is will go to 6, 7 and also 1, 2 and 4. And e-closure of 8 is 8 only. Look at this. Okay, 6, then 7 and 1, 2, 4, 8. Okay, 8. Then you have to rearrange them now. 1, 2, 4, 1, 2, 3, 4, 6, 7, 8. Right? So which is similar to B. Which is similar to B. Then delta of D, capital D comma small a, which will go to B. So which will go to B. Fill the transition table. Then so on A is over, on B can find it. So delta of capital D comma small b, we can find the transition. So you can see, look at this underlining. We have a transition from 4 to 5 on small b. Another one is 9. So 9 on B will go to 10. So that means we'll get 5, 10. Then e-closure, for this again find out the e-closure of 5. So we have to find out the e-closure of 5. It is already underlined. This is red circle has come here, and one more, it is e-closure of 10. So first you have to find out the e-closure of 5. So I'll take the 5. 5 will go from 5 without taking input, go to 6, in turn will go to 7, and also will go to 1, from 1 to 2 and 4. So look at this. I have filled the color, then 7, then on 2 and 4, this will be added to here. What is the next e-closure? The e-closure of 5 is over. You can left out with only final state, that is e-closure. E-closure of 10 will not go to any of the state, that itself. Okay, so that itself. Then you have to rearrange them, which is not similar to any other previous states label. So you have to give a new name for this. You call that is a E. Just have to added. So what is the next new state? That is E. E added to the table, capital E. So for that again find out the transition. So E closure of state E is nothing but 1, 2, 4, 5, 6, 7, 9. So now delta of capital E comma small a. So we have a transition only on state 2 go to 3, another one is 7 and 8, so 7. So these two are having transition, so only 3 and 8 will get. So E closure of delta of capital E comma A is nothing but 3 comma 8. 3 comma 8 is nothing but E closure of 3 is, will go to 3, 6, then 7, 1, 2 and 4, and e-closure of 8 is 8 only. So which is similar to B only. After rearranging them, you look at this table, which are all already they have given the same set of state, then you have to rename it. So on B. So capital B, I filled it in the transition table, then it is finding the another transition on input small b for E state. So delta of capital E comma small b. So we have a transition on B from 4 to 5, that is 5 is circle this, then another one is 7, sorry only one on B only, we have nothing, any other state will not have a transition on small b. E closure of 5 is 5, 6, 7, 1, 2, 4. Okay, look at this, all these are color coded here, so all of them added to the set, so nothing but, right, so this is nothing but 1, 2, 4, 5, 6, 7 is similar to the C, right, you do similar to the C. So we don't have any new other state, you have to stop the process. Now you got the new state, capital A, B, C, D, E. Right. Now it is a time for construction of DFA. So which is okay. So these are the state transition table. Once you get the transition table, from that you can able to write the diagram. So on A it will go to B, on B it will go to C, on B it will go to B itself, B on A will go to B on B will go to D, right? So C on A will go to B, C on B will go to C, then D on A will go to B, then D on B will go to E, so E on A will go to B, okay, E on B will go to C, right? Then you have to time for finding the final state. Which is the final state? Final state of the NFA is a 10. In this case, which state have this 10? E. E is a final state. So accepting state NFA is 10. Then 10 is element of E. Then so E is acceptance state in DFA. Okay, so with this I'll be winding off the problem. I hope you understood this concept thoroughly. Do you have any doubt? Please you have to comment in comment box. Please subscribe, share, like it. I will get the more confidence to do some more problem on this. Thank you.